Hi everybody, this is Distance Week Learning Week number 4, Factoring Special Cases. Learn a target. Today I will examine the terms of polynomials so that I can factor polynomials completely. Alright, so this first problem that we will complete, this is from last week where you have to first check your polynomial to see if you have a GCF, which if we look at the terms 6x squared, negative 27x, and positive 12, we can divide all of these terms by 3. So as a result, we have 3 times 2x squared minus 9x plus 4. Now we use this trinomial here, and we look at our setup, our organizer using our a times c term, which a is 2, c is 4, 2 times 4 is positive 8, and then our sum is negative 9. So now we have to look at which two factors of positive 8 add up to give us negative 9. Now, since we have a positive factor, both of our factors are either going to be positive or they're going to both be negative. And in this case, since our sum is negative, both factors also have to be negative. So we have two possible factor pairs, 2, 4, or 1 and 8. And in this case, 1 and 8 give us 9, and we're going to take the negatives. So we have negative 1 and negative 8. That will help us set up our box. So now we take our 2x squared term and the positive 4. And now we need to do the following. Take this section right here, the negative 1 and the negative 8. We're going to use that in our diagonal. So now we're going to set up our GCF for each column and each row. So if we look at this top row, 2x squared negative 8x, it is 2x. And then negative 1x, positive 4, no GCF at all, so it will be 1. Now, since we have a negative here, you need a negative here. So that is for the GCFs of the two rows. Look at our two columns, 2x squared and negative x. X is your GCF. The coefficients don't have a common factor. Well, they have a common factor of positive 1, but we also have an x and an x squared, so x is your GCF. And then positive 4, negative 8, it is a negative 4. Sorry about that. Because again, 8 and 4 both divisible by 4, and our signs have to match. So now our result is 3 times the quantity 2x minus 1 times x minus 4. Again, do not forget your original GCF of 3. You need to bring down in your final answer as well. So we cannot forget that at all. So now, possible binomial quadratics. So this is our general form, ax squared plus bx plus c. So in the first case, we're missing the bx term because, as you notice, you have an x squared minus 25. Now there's no no regular x term, so we could write this as x squared plus 0x minus 25. And for our other expression, 9x squared minus 4, again, no x term, so we have, this can also be written as 9x squared plus 0x minus 4. Now for these two examples, we're missing the c value. So we have our ax squared term and we have a bx term. But since there's no term that's a constant, there is no c term. And that's the case for both the 2x squared plus 12x and the 8x squared minus 10x. And in the end, we're going to show you how for these particular problems, if you're missing the c, chances are you're factoring a greatest common factor. So going back to x squared minus 64. You can also say this is x squared plus 0x minus 64. So now we figure out a times c is negative 64. So now we need to figure out what two numbers multiplied and get negative 64. Your sum is 0. Now since we have a negative product, we have to have one positive, one negative, or negative positive. And the only pair of factors that match would be negative 8 and positive 8. So then now we can set up our box x squared minus 8x plus 8x. So we get that from the figure over here, and then minus 64. So again, negative 8 and positive 8. Add them up, you get 0, and then that's going to set up your diagonal over here. So now let's factor our GCFs. So we will factor x squared and negative 8x. That's an x. 8x, it's negative 64. That's going to be a positive 8. Because remember, sides must match. Positive 8, positive 8. And then similarly, for our columns, positive x squared and positive 8x. X is your GCF. And for here, 8x, negative 8x and negative 64. 8 and 64 are divisible by 8. And since you have a minus sign on the top, you have to have a minus sign over here as well. So here we had a plus sign. You could have a plus sign here. And here, since it's a minus sign, minus sign. So now our final result is the following. X plus 8, x minus 8. That's how you factor x squared minus 64. And that example is an example of the difference of two squares, aka dots. And that's where the difference of two perfect square terms can be factored as the following. A squared minus b squared equals a plus b times a minus b. So here are a couple of examples. 16x squared minus 9, both are perfect squares. 16x squared, square root is 4x, square root of 9 is 3, and 16x squared minus 9 is factored as 4x plus 3 times 4x minus 3. Similarly, for example 2, 49x squared minus 36, factor that as 7x minus 6 times 7x plus 6. This square root of 49x squared, 7x, square root of 36, 6. Okay, so here are 4 practice problems. X squared minus 49, 4x squared minus 9, 2x squared minus 50, 16x squared minus 1. Now, for A, B, and D, we notice that the terms are all perfect squares. So x squared, remember square root of x squared is x, and square root of 49 is 7. So as a result, we see, oh, x squared is a perfect square, 49 is a perfect square. Oh, difference of two squares. Therefore, I can factor x squared minus 49 as the following. We have x plus 7 times x minus 7. That is the factored version of x squared minus 49. Now, for problem B, similar case, square root of 4x squared is 2x, and square root of 9 is 3. So therefore, as a result, we can factor 4x squared minus 9, given our little quick rule, as the following. Two x minus 3, 2x plus 3. And again, you can have plus and minus as long as you have different signs. The order of the signs does not matter. But we'll do C in a moment, but I want to focus on D first. So with problem D, 16x squared, that's a perfect square. And then is 1 a perfect square? Obviously, 16x squared, take the square root of 16 is 4. Square root of x squared is x. But is 1 a square root? Well, 1 times 1 is 1. So, yeah, we have a square root here as well. So our result for 16x squared minus 1, we can factor that as 4x minus 1 and 4x plus 1. Again, as long as your signs are different, we are good to go. So that's a quick way. And again, could you do this as the following type of problem? You can rewrite 16x squared minus 1 as 16x squared plus 0x minus 1. That's fine. You will still get the same result if you factored the previous method we used. And similarly for your other problems, if you had the plus 0x for 4x squared plus 0x minus 9 or x squared plus 0x minus 49, you will still get the same results. Now, for problem C, 2x squared minus 50. So unlike the other three, we see, wait a minute, 2 and 50 are not perfect squares. However, they're both divisible by 2. So now you have 2 times x squared minus 25. So now let's look at our x squared term and the negative 25, or x squared and 25. So we know square root of x squared, just like before, still x, and square root of 25 equals 5. So therefore, with this problem here, we can see that we have a difference of two squares. Therefore, you can factor x squared minus 25 as x minus 5 4x plus 5, and then x minus 5. So that's how we factor the x squared minus 25. Now we can't forget the 2, because that was part of our GCF. That was our GCF. So therefore, we factor 2x squared minus 50 for GCF of 2, and then x squared minus 25, factor is x plus 5, x minus 5. And again, you could say x minus 5, x plus 5, same thing. Now, you're probably asking, can we factor the sum of two squares? Maybe. You'd have to check for GCF. Yet, not like earlier. Because in the case of 9x squared plus 25, that's a prime, as in it's not factorable. You can't, so even if you put a 0x, you cannot have two factors of 9 times 25 or 225 that add up to 0. Because 15 times 15 gives you 225, but 15 plus 15 is 30. And negative 15 plus another negative 15 is negative 30. So it's not going to work no matter how you try to multiply two numbers. They have to have the same sign. So it will not add up to, those two factors will not add up to 0. However, for the 25x squared plus 100, you can still get a factor, a GCF of 25. So you can factor 25x squared plus 100 as 25 times the quantity x squared plus 4. Yet, similar to example 1, we cannot factor x squared plus 4. Because 2 times 2 is 4, negative 2 times negative 2 is 4, but neither of those sets of factors add up to 0. Now, when we're missing our C term, what you're doing is factoring the greatest common factor. So first example here, 4x squared minus 14x. We see that both are divisible by 2, and both terms also have an x. So not only do we have to factor the 2, but you also have to factor the x. A lot of us do not always remember to factor the x from each and every term, or your lowest exponent. So again, lowest exponent, in this case, lowest exponent is 1. So now, let's look at these other problems here. So for the first one, we have 3x squared minus 15x. So both terms are divisible by 3, and both terms are divisible by x, because you have an x, or x to the first, and you have an x squared. So you can not only factor a 3, but you could also factor an x. And as a result, we have 3x times x minus 5. That's our first results. Now for problem B, you have 6a squared minus 21a. Now both of these are divisible by 3 and a. So therefore, when we do our factoring, 3a is our GCF, and then 6a squared divided by 3a is 2a, and negative 21a divided by 3a is a negative 7. And that's it for that problem. Part C, again, similar to A and B, you have both terms are divisible by 5, and they're both divisible by b. So, therefore, GCF 5b, we got outside the parentheses. Now we do our division. 10b squared divided by 5b, 2b. Now, negative 5b divided by positive 5b. Now, remember, same term on top and bottom. It's a 1. Some of us have had a bad habit of just getting rid of the term altogether. If your top and your bottom are the same, you divide it, your result is 1, and then bring down your sign. Now, for this last term, 2x to the third minus 18x, this last problem, this one's going to be a bit of a challenge. Because first off, we see that both terms are divisible by 2 and x. So 2x to the third and negative 18x are divisible both by 2x. So you have 2x times the quantity x squared minus 9. Now, let's talk about that x squared minus 9 for a little bit. Let's ask ourselves, x squared, is that a perfect square? And what about 9? Is 9 also perfect square? So it turns out they're both perfect squares. We have a difference of 2 squares because x squared, square root of that is x. Square root of 9 is 3. So therefore, our result is 2x times x minus 3 times x plus 3. So that is how we factor that last problem. So it was a bit of a challenge. We had to find a GCF first, then we had the difference of squares. So our next problem is, now we're going to factor trinomials that have perfect square factors. So I'm going to look at this first problem, and you have a little hint. The perfect square trinomial. If your first term is a perfect square, your last term is perfect square, if you take the square roots of each term, and then you multiply each respective square root by each other, then you multiply by 2, or double it, we're going to figure out what's going to happen here. They're saying that we have a squared plus 2ab plus b squared factors as a plus b the whole quantity squared. Let's see what happens. So we'll do the following. We can first look at it the original way that we've done it before. So a is 4, c is 25, and as a result, that's a positive 100. And b is 20. Now, everybody's positive. So that means both of our terms are positive. So now we need to figure out what 2 terms or numbers multiplied give us 100. Add them up, we get positive 20. Result is 10 times 10. 10 times 10 is 100, and 10 plus 10 is 20. So now we have we're going to set up our box. 4x squared plus 10x plus another 10x, and then plus 25. And I should put signs. Don't need to, but you can, for positives, but it's a good idea. So now we're going to do our GCF. So 4x squared plus 10x. Our GCF of 4x squared and 10x is a 2x. And then 25 and 10x, the GCF is 5 because both numbers end in a 5 or a 0, so they're both divisible by 5. Now, for the columns, 4x squared, 10x. 2x is the common GCF, is the GCF for those 2 terms, and then for 10x and 25, just like before, plus 5, positive 5. That is our GCF for the second row. So now our result is 2x plus 5 times another 2x plus 5. But now we notice that these two factors, binomial factors, are the same. So we can say that 2x plus 5 times another 2x plus 5 is the same as 2x plus 5 to the second power. Now let's check if this little shortcut is indeed true. So what we need to do is take our square root of 4x squared and square root of 25. So 4x squared, square root is 2x. 25, square root of 25, 5. So let's say that's our A, that's our B. So now we're going to multiply 2 times A times B. So then we multiply 2 times 2x times 5. As a result, 2 times 2x is 4x, and then 4x times 5 is 20x. So you could always check to see when you take your square root of each term if it matches with the middle term. And indeed, it does. You get 20x here, and you get 20x on the bottom. So this can work. But make sure when you take your square roots of your n terms, you multiply your square roots by each other and then double it. Check for making sure you get your middle term. So that first problem, you notice how all our terms are positive. Now similarly, let's say if you had a squared minus 2ab plus b squared, again, you can take your square root of a and square root of b squared, and if you multiply a times b by 2, you can get the middle term. Even though it's a minus sign, it will still work. And in this case, if your sign of the middle term is negative, the sign between the square roots will also be negative. So I'll give you all a few minutes. Practice these two problems, x squared minus 6x plus 9 and 9x squared plus 12x plus 4, and we're going to go over those momentarily. So as we do our factoring, so a times c is 9 and the b value is negative 6. So negative 3 times negative 3 gives us the positive 9. But we add these two numbers up, you get the negative 6. And now we're going to do our factoring. So for x squared minus 3x, so we're going to take the top row, x is the result. Negative 3x plus 9, the result is minus 3. Again, the sign inside this factor box must match the sign outside the factor box. Similarly, x squared, negative 3x, x is the factor for that first column, and then negative 3x, positive 9, both numbers are divisible by 3. We have a minus sign here, also have the minus sign there. So as a result, our factor for x squared minus 6x plus 9 is x minus 3 and another x minus 3, which we can say is x minus 3, the quantity squared. Now for problem B, our factoring is 36 is A times C, 12 is our B term, and then our two factors multiply to give you 36, or 6 times 6. Add them up, 6 plus 6, you get 12. And our box will be the following. So now we set up our box. 9x squared plus 6x for the top row. So 3x is our GCF. And 6x plus 4. GCF for 6 and 4 is a plus 2. Similarly, 9x squared, 6x. 3x is our GCF for the first column. 6x and 4. GCF is 2. So then our result is, we have 3x plus 2, and another 3x plus 2, which then gives you a result of 3x plus 2. The whole thing is going to be squared. Just let me fix that real quick. Now for both of these problems, we could have also done the square root, because if we took the square root of x squared, you get x. You take the square root of 9, you get 3. And then if you multiply, well, in this case, you're going to multiply by negative. So, 2 times x times 3 is 6x. And in this case, it'll be a negative. So our middle term works for this particular problem. And for this one over here, you have square root of 9x squared is 3x. Square root of 4 is 2. And then if we multiply 2 times 3x times another 2. 2 times 3 is 6, times 2 is 12, and the x comes on down for the ride. And yes, this middle term also checks. Okay, these 4 problems, I will give you a few moments to try these problems, and then momentarily, I will review the answers for problems 1, 2, 3, and 4. So 25w squared is a perfect square. Square root is 5w. 16 is also a perfect square. The result is 4. So since we have a difference of 2 squares, our result will be the 5x minus 4 times 5x plus 4. Now let's look at our middle term. So for problem 2, we have a, b, c. So a 25 times positive 4, that's 100. And then negative 20 is your sum. So in this case, we have a positive product, but a negative sum. That means both of our terms are negative. And in this case, negative 10, negative 10. Now we're going to set up our table as the following. So we're going to factor as 25x squared minus 10x, which is 5x. Negative 10x, positive 4. GCF is negative 2. Again, the sign of the outer box must match the sign of the factor. Similarly, for the top, 25x squared, negative 10x. That's a 5x. And negative 10x positive 4, that's a negative 2. So therefore, our factoring result will be the following. 5x squared, 5x minus 2 times another 5x minus 2, or 5x minus 2, the whole quantity squared. And again, this case could have worked with our square roots, as we could have done the following. We could have said square root of 25x is 5x, or 25x squared rather, 5x. And square root of 4 is 2. And then we can multiply, in this case, negative 2 times 5x times 2, and we get a result of negative 20x. So our shortcut would have worked in this, could have worked in this case. Now, problem number 3, that is a GCF. Both terms are divisible by 3 and x. So our result is the following. 3x times 3x minus 4. That's what you do for problem 3. Problem 4 is similar to problem 2. So you do have your ABC, A, B, C. A times C is 225, because 25 times 9 is 225. And 30 is the sum. And since all your numbers are positive, we're going to have positive factors. And in this case, your positive factors will be 15 times 15, because they both add to 30, and they multiply to 225. And now our box will be set up as the following. GCF will be the following for your top row. It will be 5x. Bottom row, plus 3. And then for our columns, again, similarly, 5x and a positive 3. And then from there, we will do the following. We will list both factors, and it'll be similar to the previous. So 5x plus 3 times another 5x plus 3, and the result, we can write it as 5x plus 3, the whole quantity squared. And similarly, square root of 25x squared from before was 5x. And then square root of 9 was 3. And then if we multiply the whole thing by 2, 2 times 5x is 10x times 3. There's our 30x. And yes, the middle terms match. And for these problems, 15x squared minus 9, GCF, in this case, 3x. So our result will be 3x times 5x minus 3. Oops. Sorry about that. Now for the second problem, 8x. Now for problem 6, we have 8x squared minus 32. We have a GCF, and that is the 5. 8 is our GCF, so we can factor out an 8, and as a result, we have x squared minus 4. And this is a perfect square. You have difference of two perfect squares, so as a result, you can rewrite x squared minus 4 as the following. X plus 2 and x minus 2. So we factor number 6 as 8 times x plus 2 times x minus 2. Now for number 7, 3 times negative 8 is negative 24. The sum, positive 2. So now we need to figure out which two factors add up to 2, but we multiply to get negative 24. That is the following. I'm going to take a positive 6 and a negative 4. 6 times negative 4 is negative 24. 6 plus negative 4 is positive 2. So now we're going to set up our box as the following. 3x squared minus 4x plus 6x minus 8. And now we're going to do our GCFs. Top row. GCF of 3x squared and negative 4x, that's an x. 6x and minus 8, that is a 2, positive 2 in this case. Now for the columns. 3x squared and 6x, that is a 3x. Both terms are divisible by 3 and both have at least an x to the first power. And then for the last column, negative 4x, negative 8. It's negative 4 because both 4 and 8 are divisible by 4. And you have a minus sign, that's the leader. So you need the same minus sign here. Now, regarding number 8, can you factor the sum of two squares if there is not a GCF? Very simple, no. So, as a result, we need to go back to earlier. 9x squared plus 25, that example was prime. Because if you insert that 0x, remember, there's no two factors that give you 225 that add up to 0. That's the same case here. Can't happen because 4 times 9 is 36, but there are no factors of 36 that give you a sum of 0. It would either be positive 6 times positive 6 or negative 6 times negative 6, but neither of them add up to 0. So this last problem is prime. As we wrap it up, your extra video resources, these are in the Google slide version of this presentation. So we examine the terms of polynomials so we can factor polynomials completely. We will learn how to examine the graphs of quadratic expressions and then determine the solutions of a quadratic equation. That will be what we will be doing for the next couple of lessons starting next week. So, sum it up. You have a math space in an eCart that's open at this time, or that will be open as of Friday, May 8th. And on Monday, May 11th, there will be a cumulative review that's open. Also, I would like for everybody, the exit ticket, that's the additional factoring problems that we just reviewed. Independent practice, always the very last 2 slides, or maybe 3 depending on the presentation. Those are also practice problems. I would like for you to do the practice problems first in the Google Classroom exit ticket and the independent practice. Let me look at those as you attempt your math space and eCarts. Last but not least, you have an independent practice, problems 1 through 5, all special case problems, and problems 6 through 10. Factor your GCF first, then do your factoring. Some cases for 6 and 7, it might just be a GCF. 8 and 9, those are special cases. So is 10, special case. As always, email me if you have any questions. Thank you so much, everybody, and we'll be in touch. I'll see you soon. Stay safe.